All right, here they give us parametric equations. They want us to sketch this curve out. All right, so we'll use the calculator to help us here. All right, remember to, if you want to be in parametric, you have to go down here. And this one we want to make sure we're in radians as well because we can see it's in radians. And then the next one down, make sure parametrics is the one selected. So now let's go to our graphing one here. We'll type in our two functions. So for cosine. Now when you hit this variable button, it should put t in there. And then we want -1. And our other one we'll type in here. So this is 3 sine t. Close it up, and we got +2. All right, and now they give us this range here, that or domain for t, so we want to make sure that's in here too. So in our calculator, we'll go to our window here, and we want our t minimum to be 0, and we want our t max to be 2 pi. So you can type in 2 pi here and hit enter. This t step, I had it set at 0.05. That should be good if you put it there. So now let's graph this out, see what this is going to look like here. Now it's starting to graph. Kind of hard to see it all. I'm going to change this. Let's go zoom and let's do our standard graph here. Might be able to see it a little better. There we go. Okay, so it looks like we get what's called an ellipse is what we're graphing here. So we want some points now to graph this. Let's go to our table and see if we can find some points here. Now you can see at 0 there is a point here at 3, 2. So we know 3, 2 is a point. The rest of our points not very good for graphing here, but that's because we're going by ones. And if we're dealing with 0 to 2 pi, it must mean we want to go in and have our table go by things with pi. So let's go to our table here. Let's have our table start at 0 because that's where our t starts, and let's have our change go by pi over 2. Then we should get some better values here. So now if we go to back to our table, there's some better values. So we can see at pi over 2, it's going to be, there's a point at -1.5, which is right there. At pi, it's -5, +2, and at 3 pi over 2, it's -1, -1. And then at 2 pi, it's back to 3, the 0.32. So we've made a full loop around this ellipse here. So here's our graph. And remember, with parametrics, you want to show the direction it's moving here. So not the best drawn ellipse there, but that's what we're graphing. All right. Part B, find dy dx. So now they want us to find this derivative. So our dy dx here is our derivative of y over derivative of x. So let's find that. Derivative of y dy dt here would be 3 derivative of sine is cosine t, and derivative 2 is 0. So that would be what we have on top here. Over our dx dt over here is going to be derivative of cosine is negative sine, so -4 sine t. And derivative of -1 would be 0. So that's our derivative. Another way, if you wanted, that you could also write this would be that dy dt, because we got cosine over sine, we know that's the same as cotangent as well. So that would be another way you could write the answer. Either one's fine there. All right, let's look at part C. Same problem here. Find the equation of the tangent line when t equals pi over 6. Okay, so this could be one where, like, on the test, you could possibly have this one without calculator, so let's practice doing this without a calculator. We just had our equation there that our dy dx, and we want to find this at pi over 6 to get our slope, was equal to 3 cosine of t, so 3 cosine pi over 6 over -4 sine of t, so pi over 6. All right, so now let's see if we can figure out what that is. Pi over 6. If you can't remember what that is an angle of, remember you can convert back by timesing by 180 over pi into degrees. So 180 divided by 6 is 30 degrees. So we're dealing with a 30-degree angle here. So if we have a 30-degree angle, that's 30 degrees or pi over 6. And you got it in the unit circle, what's that going to be? Well, in unit circle, that's 1, which means the small side's half of that from 30, 60, 90 triangle, and the side square at 3 over 2. So if we're doing cosine of that, cosine's adjacent over hypotenuse, this would equal the square root of 3 over 2. And sine would be opposite over hypotenuse, so that would be 1/2. So it looks like if we simplify this here, we got 3 square roots of 3 over 2. The bottom's going to simplify to -2. If we multiply by reciprocal here of -1/2, this will cancel down here, so it looks like our slope becomes -3 square roots of 3 over 4. So that's our slope. Now we need the points. Okay, so we need our points here. What are our points going to be? So our x value at pi over 6 would be 4 cosine pi over 6 minus 1. Cosine again comes out to be square root of 3 over 2. So we got 4 times square root of 3 over 2 minus 1. That's going to be 2 square roots of 3 minus 1. Our y value is going to be 3 sine of pi over 6 plus 2. Sine comes out from before, we know that's 1/2. And so we get 3/2 here. I'm going to just make this into a fraction. So 2 is the same as 4/2, so it looks like we get 7/2. All right, so now last step, put this in equation form for the tangent line. So we got y minus, our y value came out to be 7/2 equals, our slope here is -3 square roots of 3 over 4. And then our x value came out to be 2 square roots of 3 minus 1. So that would be the equation of the tangent line. All right, last part to this, they want eliminate the parameter to find the Cartesian equation. Cartesian equation, that's where t is no longer a part of it. In this one, since we have cosine and sine, the way we're going to relate this together is to use that Pythagorean identity where we know cosine squared plus sine squared equals 1. So in this case, we would have cosine squared of t plus sine squared of t should equal 1. So what we want to find is what are these equations in terms of sine and cosine. So over on the side here, let's find those. Let's start with the x one. So x equals 4 cosine t minus 1. Let's solve for the cosine. So add 1. Divide by 4. So cosine of t is equal to x plus 1 over 4. So we can substitute that in over here. And it's cosine squared, so this is going to be squared. Plus, now let's do the same for y here. So y equals 3 sine t plus 2, so minus 2. And divide by 3, so it looks like sine of t is equal to y minus 2 over 3. So we'll substitute that one in as well. And that's also squared equals 1. And so it looks like the equation of this one would be that, or if you wanted, we could square the bottom. So it'd be x plus 1 squared over 4 squared would be 16 plus y minus 2 squared, 3 squared is 9 equals 1. And that would be the equation of that ellipse that we had graphed originally out on the problem there.